Hello and welcome. My name is Eric Fleming, and this is my counterpoint video on cross-site scripting. And my counterpoint is that it's a lot more problematic than we think. But first, before I jump into it, I wanted to thank Ethan Lin for his presentation. It was really helpful that he went over the three different categories of cross-site scripting attacks. I'll touch on two of the three because I think that there's not a lot of moving pieces to understand. We'll talk about some of the countermeasures that we could implement. So as I was just saying, yep, we're going to go over common attack vectors for two different types of cross-site scripting attacks. The first is a reflected XSS attack via email, and the second is a stored cross-site scripting attack from the HTML forms. So your first attack vector, your inbox, you've got mail, in other words. This is where, the people who are not used to using technology all the time, they probably haven't heard this age-old wisdom that if you don't know who sent it, don't click on any of the links. And this comes down to a cross-site scripting reflected attack. Unfortunately, sometimes we can get tricked by maybe the first 20 letters in the email address are like, oh yeah, I recognize that name. And then you look, it's like, oh, from at hackerserver.net, but it's so far out there you don't even read it, or they've somehow stolen all the images from the page. They get their own emails from this company, so their typography is exactly the same, and you click on it and there it goes. So the steps at which this attack is taken: first, the hacker has to make a malicious link that includes some JavaScript that will later get executed that you don't want executed. When it gets sent to your inbox, you get duped, you click on it, it then redirects you to another location. That location elicits a response, and that response gets sent back to your computer. And what it does is, since you've clicked on it from the session that you were in, it has access to that information, so it can expose data about the cookies that are associated with that service and or session IDs. Let's see. All right, so the second type, which is a little bit more invasive, is a stored cross-site scripting attack. This one we have to think a lot more as developers because we're the ones that make it. In other words, the common culprits are input fields for text, and these are classically found on comment threads, blogs. I mean, forums have kind of been taken over by social media in general. So those are more large centralized platforms, but every once in a while, Google once every 10 years might have a problem with it. But the main idea is that it doesn't matter if you do it 99% of the time right. The 1% of the time, or not even that, the thousandth of a percent time that one input field isn't properly countermeasured, you can then insert your own JavaScript into that form, and what it'll do is it'll get stored in their database, and when other people visit that page, it'll then queue up that script that you had stored, and that's the base point from which they're going to launch the attack. Looking at this example right here, this is just one little exploit. So the image tag has a path to the source of the image, but if you notice, source doesn't really have a path. So there's this optional attribute called onError, please notify that I should do something else. But that onError allows you to type your own JavaScript in there. So that's kind of the entry point in the HTML tag that you're uploading to the server. All right, so 4 steps to that, like I was saying. You type the malicious JavaScript into the form because it's not properly countermeasured. It's going to get uploaded, and then when someone requests that page, it's going to then get downloaded to the user's browser, and then it's going to get executed on that page. So similarly to how the email works, it involves directing them to a site that hosts the malicious code. So up here at the top, where this is where the redirection is happening. So it's going to take you to this URL, and then it's going to post the cookie to the URL parameter, and then you'll be able to take a look at it. Another one, this is an old exploit with PHP. This implies that you have access to your own server. So essentially it's the same thing where once you get redirected to the page that this is on, it's going to ask for the session ID. It's going to open a file on your server, and it's just going to write it to there. But the same mechanisms of how you get to this script is involved through a redirection that you didn't know that got inserted into the page that you were on. Okay. So why is this problematic in general? Well, the first is that we have all of these countermeasures that I'm going to highlight later, but there isn't like a shared body of governance that actually stipulates that these need to be done. They're all recommendations, unless of course, you know, it's a government application. But outside of that, which is, you know, most of the web, it's up to you, the company, the developer, to decide, are you actually going to implement these? I think this is a lost opportunity. I think hosting providers could provide a pretty clear early line of defense against this. One of the countermeasures I'll talk about later is going to address that, but you could alert users to whether or not their website has a certain number of vulnerabilities, and then issue demands saying we're going to cut service if you don't do these after such a time. And if you do notice that it has those vulnerabilities, you know, provide them the resources and the outlets to fix them. That would be what I would want. Another thing is too, well, that's pretty costly, right? Like, who would want to sign up for a service knowing that you could get thrown off the service at any time? That just says to me that when HTML and JavaScript were first invented, that this idea of security was sort of like not even on their minds at all. It doesn't come fundamentally with the platforms themselves. So it doesn't, it seems pretty reasonable to me that some of these countermeasures could be implemented natively, but again, they're not. So I question why that is. And then finally, of course, everyone's moving to the internet. Many new industries that don't have technical expertise, so they're going to hire other people to do it. And when it comes cost versus security, deep down we know that more people are going to choose cost, lowering cost over heightened security. And so the economic pressures against being secure are staggering, and that's why this is problematic. So some of the countermeasures. First is that if you want to go ahead and up your security, don't assume that you can do it all on your own. Don't assume that you can spot all of the specific edge cases. You really should pay for a testing suite. And that's why I was saying, well, the hosting providers could go ahead and they could tell you this, because we have these testing suites. The hosting providers could buy these testing suites, and they could run them on your website and notify you, hey, by the way, we noticed you have these vulnerabilities. But again, they're pushing that cost onto you. So I think that that's something that could be done more broadly. There was this idea of making sure that your unique tokens, like your cookies and your session IDs, making them shorter-lived, so that even though someone gets access to them, they only have so much time to exploit it before the locks change on them, and then it's not good so anymore. But of course, as we saw with the stored cross-site scripting attack, if you get in there and you store it on the server, hey, it's there. So we got to make sure that we're not storing things that don't belong there on the server. And that's where the third bullet point comes in. That's where input validation and input sanitization for your application are the primary modes of defense against cross-site scripting attacks. But again, you don't really want you to have to implement these yourself from scratch. this is a known problem. So you want to seek out frameworks that have good security tools that'll do the validation and the sanitization for you. And last but not least, certainly update your browser. Your browser is going to have some built-in defenses for what it thinks is malicious code or not. And so always making sure you have the updated browser is kind of be that last safety net. So here are some recommendations for testing suites that one of the papers articulated. I really liked number 2, just because of the companies that used it. AWS says that, or they advertise that AWS uses it. So if Amazon signed off on it, I think it's pretty good. They have a lot of sensitive business that they need to conduct. So input validation. Essentially, this is screening your inputs before your application is even going to handle them. So even if you need angle tags or not, we can't run a script without those angle tags. So you can just prevent those from even being entered into the system in the first place. Of course, there are situations maybe where you do need them, so that's where it's going to come down to your specific use case about what you want to validate. Another thing that I'm a fan of is input length. It'd be pretty hard to have a hacking script that's only 4 characters long, if we're talking about a year. And then also sending enumerated values as opposed to actually sending the strings themselves. So this comes down to how you design your system. But a popular phrase I learned in one of my classes is the data is not the model. So in other words, the user can type in data, but that data doesn't have to be what's actually sent across the wires. So that's an important thing to think about. You can have categories and then send a few numbers across, and then that represents the malicious data hypothetically, and then you build it on your server, but since you're the one that's building it, you'll do it so in a safer way. But then we come to the best defense, the best countermeasure, which is the input sanitization. So in other words, eliminating, replacing, or escaping characters that are used in JavaScript to conduct these exploits. This photograph right here is a toy example, like I was saying. You don't want to build these sanitization functions from scratch. It's not as simple as just saying, oh, I'm going to march my way down the input string, and when I see this character, swap out the angle bracket for and LT semicolon. There's different combinations that would on their own appear to be not malicious, but then when JavaScript evaluates them, it turns into malicious code using hex values. I saw a PHP exploit in another paper that used an array and was able to comment out part of one of the array indices, and then that was able to leak in an apostrophe because the previous code evaluated to nan, and then so it didn't get kind of used. So I didn't think that exploit was branched off of that, but they were able to get an unsanitized apostrophe input to the server bypassing, whatever function that they were using at the time. So here are the rules for data sanitization. Essentially, anytime you're using JavaScript to change anything on the browser or the web page, go ahead and use a pre-built sanitizing function. Here are some popular resources for doing so. But again, if these are libraries that exist on GitHub or out there in the open source community, I'm wondering why these aren't native, right? So again, that's why I think it's so problematic, is because you have to know about these libraries. It doesn't come just with the language, so you have to do all this extra digging. And then finally, updating your browser. So some of the XSS auditors, they take different approaches. Some of them look at the incoming data, and some of them actually construct the DOM tree so that they can look at all of those hacks I was talking about, where when it's coming in, it looks not malicious, but then after the JavaScript kind of does its data transformations, its output is actually malicious. So looking at it from both angles, when people have these leaks, your browser is able to react to it, and making sure that you have the most updated browser is going to make sure that these auditors inside of Chrome, Safari, Firefox, they're going to be able to catch them and not execute them on your page before it loads. So here are my references, and thank you guys for listening to my talk. I believe that cross-site scripting is a problematic endeavor, not because countermeasures don't exist, but because you have to go through a lot of work to implement the countermeasures, and we don't have fast feedback systems, and we don't have top-down governance for implementing them. So thank you.